Howdy! This is a lesson on simplifying radicals. The essential question is, what does it mean to simplify radicals? Let's begin. So this is an optional lesson if you don't know how to do radicals. So radicals look like this. You got the root symbol on top, and you got the number, which is the radicand, on the bottom. We can simplify radicals like square root of 21 to 11, or square root of 150 to 5 radical 6, or square root of 48 to 4 radical 3. But how do we do that? Well, first, what does simplified mean? Simplified means that the square factors are removed from the radicand. So the radicand is the thing inside, so the square factors get moved to the outside. So for example, square root of 121 is 11 squared. 11 is the squared factor, so that 11 gets moved to the outside. There's nothing left inside, so it's just regular 11. For square root of 150, that can break apart into 25 times 6, which is 5 squared times 6. That 5 is the squared part, so that 5 comes to the outside, and now we get 5 times square root of 6. With 48, it's 16 times 3, which breaks down to 4 squared times 3. That 4 is the squared factor, so it's moved to the outside, and we have 4 radical 3. So that's what's going on here. Now the question is, how do I simplify radicals? And there's more than one way to do this, and I was looking for videos the way I do it online, and just a quick 1-minute a search, I couldn't find any, and Khan Academy doesn't do it my way, and I like my way, so I'm going to teach you my way, because it works all the time, and it doesn't matter what size the radical is, and it doesn't matter if you can't identify perfect squares. So the first thing to do my way, you have to know the divisibility rules, and you can Google search that, and you'll find a bunch of different stuff on that online. Basic idea is, hopefully you can understand when it's 2, the last digit is even, that means you can divide it by 2. For 3, it means the sum of the digits are divisible by 3. So you should be able to recognize those. 5 is the next easy one. The last digit is 5 or 0. 7 is a weird one, and there's some weird rules for this. I don't know how that works. You just check you can divide it by 7. And everything after that is basically some version 2, 3, or 5. I mean, these are going to be the main numbers besides other prime numbers. We're talking about prime numbers to be divisible. So 2, 3, and 5 are the main ones right now. Step method. This is what I call it. So basically, we create these steps, these kind of upside down steps, and those will give me my factors. So the first step I do is I write the radicand and create the first step. So the radicand is 50, so I'm going to create a 50 and then make my first reverse step. There's the step. All right. Next step, I want to write a prime factor on the left and divide by that factor. Put that answer below and repeat until I'm left with a prime. So this is the way it works. I take that 50 and I say, what prime factor can I divide into 50? Usually I start with the lowest number, 2. So 50 is an even number, so I can divide it by 2. I write a 2 on the outside, and then we go 50 divided by 2 is going to be 25. So I have a 25 out here. Since this is not prime, I make another step, and I keep repeating this. What can I divide into 25? Well, not 2 anymore, not 3, but I can divide 5. And 25 divided by 5 is left with 5. 5 is a prime number, so I don't make any more steps. Now, for step 3, I circle pairs, and I square alones. So when I square alones, it means I literally put a square or a box around it, and I circle the pairs with a circle. So this case, we're looking at the outside. This 2 doesn't have any other 2's to pair up with, so it's a square. And I have 2 5's, so I circle those. So I've circled the 5 and squared the alone. Now, putting pairs on the outside and on the alones inside. So basically, in every alone here, I put inside, so just a 2 on the inside. Since I have a pair of 5's, I put a 5 on the outside. And my simplified form is 5 radical 2. That's the steps. So I'll try this a few other times in this video, show more examples. 121 you can still do in the same way. You can factor out 11, and you're left with 11. So then 11's prime, and now I have 2 factors of 11. And so that means I have 11 on the outside and nothing in the square root in here, so it's just 11, which checks out. For 150, I can divide that by 2, it's even, so it gets down to 75, and then I can divide that by 5 because it ends with a 5, and then I get 15, and I can divide 15 by another 5, and I get 3, and 3 is a prime number. Well, I will circle pairs. I have a pair of 5, and this 2 doesn't have a friend, and the 3 doesn't have a friend. So what I have is outside of a pair of 5's, so that goes to the outside, and I have a 2 and a times a 3, so 2 times 3 inside, and that simplifies 2 times 3 is 6, so 5 radical 6, which matched up what I said before. The last one for 48. Well, it's even, so I'm going to divide by 2, and I get 24. It's even again, so I'll just keep going. And I'll keep going until it stops being even. And I'm left with the 3. Cool. Now I circle pairs. A pair of 2's and another pair of 2's. But then I have a lone 3. So on the outside, my square root, I have a 2 pairs of 2's, so it'll be 2 times 2. And then a 3 inside. 2 times 2 is 4, so it's 4 radical 3. And that's a simplified form. That's it. I'm going to try some more examples, so pause the video. Alright, simplifying these, again, I'll just go through it really quick. 98 divided by 2, 49. Divides by 7 and 7. So I have a pair of 7's and a lone 2. So I get 7 radical 2. For 18, I can divide it by 2. I get a 9. And that's 3 and 3. And for 19, I have a lone 2. And I have a pair of 3. So I get 3 radical 2. Now for that last one, 192. It's a bigger number. We could still handle that. Divide by 2. It's the first thing I notice. And then it'll go in. 19 goes in 9 times. 96. I can divide that one by 2. So I get 48. I can divide that by 2. I get 24. And by 2, I get 12. And 2. And I get 6. And 2. And I get 3. That went really deep. Now I can circle the pairs. And I have a pair of 2's. And another pair of 2's. And another pair of 2's. And a lone 3. So I have 3 2's on the outside. So it's 2 times 2 times 2. Inside I have a 3. So it's going to be 8 radical 3. 2 times 2 times 2 is 8. Alright, try this example. Oh boy, it's a big number, 4 digits, but that's okay. We can break it down. So, first step, it's even, because that's what I start with. So divide it by 2, so I'm left with 704, and it's still even. So divide it by 2 again. I'm left with 352, and it's still even, so 2 again. I'm left with 171. Is that right? 76. 176. And I can divide that by 2 again. So I'm left with 88. And I'm left with 2 again. I'm left with 44. I'm left with 2 again and 22. And 2 again and 11. Hey, that broke down. 11's a prime. So I'm going to circle my pairs. Let's do that different color. I'll undo those. Circle my pair, my pair, my pair. Okay, this 2 doesn't have a friend, so I just square it. And this 11 doesn't have a friend. So I have 3 pairs of 2's on the outside, so 2 times 2 times 2. And then I have a square root of 2 times 11. So that becomes 2 times 2 is 8. 2 times 11 is 22. 8 radical 22. And that's my simplified form. That's it.